Welcome. Today we're tackling Newton's second law, arguably the most useful equation in all of physics. F equals ma. By the end of this lesson, you'll solve real problems with confidence. Let's go. Why should you care about this equation? Think about it. A fully loaded truck needs about 10 times more distance to stop compared to a small car going the same speed. You can throw a tennis ball way faster than a bowling ball, even though you use the same arm strength. And rockets burn millions of pounds of fuel just to get off the ground. All of these are explained by just 3 letters. F equals ma. Here it is. Newton's second law says that the net force on an object equals the mass of that object times its acceleration. Pay attention to the word net. That means the total, the sum of all forces acting on the object. If you push a box forward with 50 newtons, but friction pushes back with 10 newtons, the net force is 40 newtons, not 50. Let's nail down the units. Force is measured in newtons, abbreviated capital N. 1 newton is defined as the force that accelerates 1 kilogram at 1 meter per second squared. Mass is in kilograms, and acceleration is in meters per second squared, which tells us how much the velocity changes each second. For example, an acceleration of 5 meters per second squared means the object speeds up by 5 meters per second every second. Here's the key insight that makes this equation so powerful. If you double the force on an object, the acceleration doubles. Triple the force, triple the acceleration. But what about mass? If you double the mass while keeping the force the same, the acceleration is cut in half. Force and acceleration are directly proportional. Mass and acceleration are inversely proportional. This is exactly why that heavy truck is so hard to stop. You can rearrange this equation 3 ways depending on what you're solving for. Need force? Multiply mass times acceleration. Need acceleration? Divide force by mass. Need mass? Divide force by acceleration. Let me show you each one with real numbers. Let's start simple. A 2-kilogram ball has 10 newtons of force applied to it. What's the acceleration? Step 1. Identify your knowns. Force is 10 newtons. Mass is 2 kilograms. Step 2. Choose the right form of the equation. We want acceleration, so it equals F divided by m. Step 3. Plug in the numbers. 10 divided by 2 equals 5 meters per second squared. The ball accelerates at 5 meters per second squared. Easy. Now let's find force. A 1,500-kilogram car needs to accelerate at 3 meters per second squared. How much force must the engine produce? We know mass is 1,500 kilograms and acceleration is 3 meters per second squared. Using F equals m times a, that's 1,500 times 3, which equals 4,500 newtons. That's about 1,000 pounds of force. Now you see why car engines need to be so powerful. Now here's where it gets interesting. A 5-kilogram box is pushed with 30 newtons, but friction pushes back with 10 newtons. What's the acceleration? The crucial step is finding the net force first. 30 minus 10 equals 20 newtons net. Now divide by mass. 20 divided by 5 equals 4 meters per second squared. Remember, always use net force, not just the applied force. This is where many students make mistakes. One more example. An unknown object accelerates at 8 meters per second squared when 40 newtons is applied. What's its mass? Using m equals F divided by a, that's 40 divided by 8, which equals 5 kilograms. Scientists actually use this technique in real experiments to measure mass by measuring force and acceleration. Here's a special and very important case. Weight is actually just F equals ma, where the acceleration is gravity. We write W equals mg, where g is 9.8 meters per second squared on Earth. If your mass is 60 kilograms, your weight is 60 times 9.8, which equals 588 newtons. On the moon, where g is only 1.6, you'd weigh just 96 newtons, but your mass stays 60 kilograms. Before we finish, let me address the number 1 mistake in physics. Many students think you need a force to keep an object moving. That's completely wrong. You only need force to change an object's motion, to speed it up, slow it down, or change its direction. An object with zero net force keeps moving at constant velocity forever. This is Newton's first law. A hockey puck slides across ice precisely because friction is almost zero. Let's recap everything. Newton's second law, F equals ma, is the foundation of mechanics. You can rearrange it 3 ways to solve for any variable. Always remember to use the net force, the total of all forces. Weight is just a special case where the acceleration is gravity. And most importantly, force changes motion, it doesn't cause motion. Practice these examples, and you'll master this equation in no time. Great work today!